In this lesson, we are going to talk about how the wireless network makes communication with other network devices more convenient using two elements: wireless routers and wireless access points. Before we dive in, a quick did you know to illustrate the importance of studying cybersecurity. If you don't believe this quote by Ginny Rometty, the longtime face of IBM and one of America's most prominent female business leaders, then think about this. According to PurpleSec's ultimate list of stats, data, and trends in cybersecurity, in 2018, there were 80,000 cyber attacks per day in the US and over 30 million attacks that year. It's a fact. Cyber attacks are the fastest growing crimes in the US today. So, what aspect of cybersecurity are we going to be looking at today in Lesson 3? We'll start by looking more in-depth at a wireless router and wireless access point. We will then discuss wireless adapter functionality and benefits and some network capabilities for adapters. We'll end off with a section on some common deployments of a wireless network in the business world. We will explore local area network, LAN technologies and their benefits, examine wide area networks, WAN technologies in more detail and discuss their benefits, and learn more about personal area network, PAN technologies, and their benefits and limitations. Let's dive right into the first section of this lesson by introducing you to wireless routers and access points. Wireless networking is when network devices communicate wirelessly using radio waves that travel at different frequencies. And these frequencies are captured by a wireless adapter. A typical example of wireless networking would be the use of a Wi-Fi hotspot in a coffee shop, restaurant, or at a school or office. Do you remember our discussion in Lesson 2 about some of the benefits of a wireless network? A wireless network depends on other wireless network devices such as a wireless router or a wireless access point. So what is a wireless router? A router is a network device that transmits data from one subnet to another. A wireless router serves as a mediator between the WAN, wide area network, and the LAN, local area network. It transmits data from the LAN to the WAN wirelessly without the use of cabling. Wireless routers come in different forms such as a modem, wireless broadband, and a router with wireless abilities. So basically, on a wireless network, the devices that are connected can share data and resources wirelessly, simply by assigning IP addresses from a DHCP server on the wireless router. So what is a DHCP server? DHCP stands for Dynamic Host Configuration Protocol. The DHCP server plays a vital role in connecting devices. Once configured, it will automatically assign an IP address, default gateway, which is the point of exit from the LAN to the WAN, and other parameters. A DHCP server uses a standardized protocol to send broadcast queries from the host to the user's laptops, computers, or network printers. Now, since the DHCP server assigns IP addresses to connected devices, it can also be used for IP address management, IPAM, for tracking connected devices and for forensics, such as data analysis. Since the DHCP server assigns IP addresses to connected devices, it can be used for tracking connected devices and for forensics, such as data analysis. In companies, there is always a need for security when it comes to data. A critical part of organizational security today is being able to manage the devices in circulation within the organization. Another function of a DHCP server is IP address management. When a DHCP server assigns an IP, a log is automatically created of the IP device it was assigned to, and time and duration of the lease. Now, all this information can be saved on the server logs and used by the network administrator. We said earlier that a wireless network depends on wireless network devices, such as a wireless router or wireless access point. We've chatted about wireless routers. So what exactly are wireless access points? Wireless access points are network hardware components, either a single device or a built-in component in a router that aid connections to other connected devices. As shown in the diagram, modern WAPs like the Cisco Meraki offer a cloud-managed access point to provide additional security functionality, such as advanced malware protection. For those who don't know, Cisco Meraki is a cloud-managed IT company whose products, such as wireless, switching, enterprise mobility management, and security cameras, are all centrally managed from the web. It is arguably the industry leader in cloud-managed IT. A wireless access point has a lot of functionality when it comes to connecting devices, but there are two main functions. It offers increased efficiency. When a WAP is connected to a router without Wi-Fi capability, the WAP serves as a medium between the router and other network devices, transmitting data from the router to the access point, and packets or data are transmitted wirelessly to the connected devices in the network. It also offers enhanced network coverage. A WAP can be used as a form of wireless extender to boost network connectivity. Businesses that adapt to WAP stand to benefit a lot from introducing wireless access points in their network. These benefits include convenience. WAP offers a high efficiency level in close proximity to their devices. This greatly speeds up the connection time and increases the user's capacity. To explain, a router usually comes with fewer ports, but with WAP, there could be more users connecting to the network. Another benefit is versatility. Users do not have any restriction with network cabling, as is the case with a wired connection. Any user connected to the wireless access point could clearly move these devices and stay within the network proximity of the wireless access point and still have connectivity to the network. Productivity. Users can simply connect to any WAP close to their location and keep up with their day-to-day tasks while on the go. Most businesses usually have centralized resources for their employees that are easily accessed in areas where WAPs are present. Another benefit of a WAP is administrative control. With the benefits of the IP address management (IPAM) network mentioned earlier, administrators can log in to view end-user experiences and reports. The IP address management network can also aid detecting vulnerability and attacks across all channels. And last but not least, there's the benefit of security and protection. WAP have their own built-in identity-based firewalls. In advanced WAPs such as the Cisco Meraki, the administrator will be able to log in to manage firewall rules, set tags to isolate users, and limitations for bandwidth in the network. Now let's look a little closer at the networking capabilities of the interface adapter. In the real world, you just click a button to connect to your wireless access point. We would like to show you what happens behind the scenes when you connect to a wireless access point. We'll be using a virtual machine to show these capabilities with step-by-step screenshots. Later in this lesson, we'll take you through the installment process of virtualization. Let's get started. We'll be running some basic Linux commands on command line interface on our laptops to show the interface information and scanning wireless access points in close proximity to laptops. Firstly, by typing in this command, you will see all the interfaces on your laptop. On our virtual laptop, here you can clearly see that there are 3 different interfaces. The first one is an Ethernet adapter for a wired network. The second one is the Loopback Internet Protocol IP address, often referred to as the local host. It is used for testing and troubleshooting on an Ethernet interface. The third adapter is for a wireless network. You would type in the following command to display the wireless adapter interface only. On our virtual laptop, you can see the MAC address for the laptop. Note that there is no IP address. Type in the following command to show more of the configuration of the wireless adapter. The information you will see is the supporting wireless adapter. This refers to the technical term for a network name, such as the name of the Wi-Fi network, such as the coffee shop hotspot. Managed mode refers to the monitoring of all traffic received on a wireless channel. There are other various modes with the wireless adapter, such as promiscuous mode, used for capturing packets without having to associate with an access point, and master mode, where the wireless adapter acts as an access point to other connected devices. Note that there is no access point associated to this wireless adapter. We will be returning to wireless configuration in more detail later in this lesson when we come to exploring network vulnerability. Type in the following command to scan for a wireless access point in close proximity. You will get the following information from the completed scan: the MAC address for the access point. We can also see the frequency the access point is on, which is 2.4 gigahertz, and it is broadcasting on channel 6, as well as the signal strength. We can also see that the access point does have some form of encryption, and the access point is named Solar. The access point is in the master mode, which means this access point could serve as a point of access to other connected devices. We can also see the encryption type and what standard the wireless access point supports. There is obviously lots more info than that, but that's a pretty good start, don't you think? We can also run some commands to see the rate of transmission, as well as the frequencies the channel is operating in. Like this command. To display the frequencies the channel is operating in, you would type in the following command. We can see that there is a total of 13 channels and the frequency they operate in. We can also see that we are currently connected on channel 6. Wasn't that fun? Let's break here for a quick did you know. You might already know that the distance between your wireless adapter and router can affect your internet speed. A general rule is that if you double the distance between the router and client or device, it decreases by 1/3 of its original strength. Let's now look at some network software that supports networking capabilities. IEEE 802.11 is the wireless radio standard used to facilitate the networking design and implementation of security protocols in wireless networking. In terms of supported areas, 802.11 outlines the IEEE specification when it comes to wireless networking. These standards differ in the range of speed, transmission, and frequency. The 802.11 wireless standards initially offered 2 modes and used 1 or 2 megabytes per second transmission speed with a radio frequency of 2.4 gigahertz. Data was transmitted using frequency hopping spread spectrum, FHSS, or direct sequence spread spectrum, DSSS. We'll talk about these terms just now when we look at a table comparing common 802.11 standards. Let's look at a table comparing some common IEEE 802.11 standards. All these standards use the Ethernet protocol and the carrier sense multiple access or collision detection access method. To explain some of the terms, OFDM, orthogonal frequency division multiplexing, has transmission operations that have the capability to transmit a larger amount of data on separate frequencies. Splitting the signal on separate frequencies greatly reduces the amount of interference. OFDM is mostly associated with IEEE 802.11, 802.11g, 802.11n, and 802.11ac wireless standards, and is used in 4G mobile phones. DSSS, direct sequence spread spectrum, operates with the transmission of signals spreading over a full transmission frequency spectrum to reduce the impact of interference during transmission. DSSS is commonly used in telecommunications. And then FHSS, frequency hopping spread spectrum, dictates the application of narrowband signals that change frequencies in an anticipated pattern. An example of this is Bluetooth. We started this lesson by explaining that wireless networking is when network devices communicate wirelessly using radio waves that travel at different frequencies. And these frequencies are captured by a wireless network adapter. So what is a network adapter? A network adapter is a component of hardware that aids the connection from devices to a network. It maximizes performance and greatly increases productivity for end users. Basically, when a wireless network adapter is plugged in, it scans the network and implements auto negotiation to find the highest network speed and bandwidth capability. When choosing a network adapter for any of your end devices, there are some key factors to consider. They are speed, the transmission rate of data in the network adapter. So how fast is the upload and download speed? Then capability, the specification of the network adapter. So how many channels can the adapter use in transmitting data? Then functionality, the features of the network adapter. So exactly how does it transmit? And then finally, price, the overall cost of acquiring the network adapter. We have reached the last section of this lesson. Here we will be looking at some common deployments of wireless networks in business settings. There are three main structural components of deployment that apply to working environments, and we'll discuss each one separately. They are centralized deployment, converged deployment, and cloud-based deployment. Before we look at each one, I must mention that most business owners would get advice from a consultant before implementing any of these structures because they're all rather complex. Centralized deployment is typically used in businesses with buildings, units, or campuses in close proximity. This deployment type could be configured as a hybrid network with the use of wired or wireless controllers to boost and acquire advanced wireless functionality. A centralized deployment is designed based on the premises and all the equipment is installed in one location. Converged deployment is typically used in smaller businesses, campuses, or branch offices. The deployment architecture is either wireless or wired connections or a combination of both. The network policy is on the controller to efficiently manage unnecessary traffic queries, thereby implementing a single policy on both the wired and wireless traffic. And then in cloud-based architecture, there is a significant benefit in the use of cloud technologies to manage network devices that are either on premises or at a branch office. As mentioned earlier, Cisco Meraki is a good example of fully optimizing your network using cloud-based deployment. Let's start with what is LAN. A LAN is a collection of devices connected in one location, such as office buildings and learning institutions. Do you remember our demo in Lesson 2 where we set up a network for a coffee shop? All the laptops were able to ping each other because they were all in the same local area network. The size of LAN is relative to the number of devices that are connected in the network. A LAN is usually limited geographically, but can be connected to a larger geographical area with a WAN or MAN. We'll talk about WANs next in this lesson, and MAN is the abbreviation for a metropolitan area network. LANs comprise of many different components that aid the connection, such as cables, access points, switches, etc. These devices are vital in the architecture of the LAN setup and the link to a WAN or MAN. Did you know? A metropolitan area network, MAN, is a computer network that interconnects users in a geographic region of the size of a metropolitan area. MANs are connected across multiple buildings and are bigger than the standard LAN, but not as large as a WAN. Wider area network, which is usually found in big campuses, cities, and even large companies. But we'll talk more about WANs just now. LAN technologies can either be client or server or peer-to-peer. The type of devices that are used depends solely on the type of LAN technology to be implemented in the network. Let's look at each of these a bit closer. If you look at this diagram, you will see that a client or server LAN contains several devices belonging to a client or workstation that are connected to other devices that act as the server. The connection between the client and the server can be wired or wireless, depending on the user's preference. Servers have many different functions such as file storage, application access, device access, and even managing the traffic of the network in the LAN. In the case of a peer-to-peer local area network, there are no centralized servers sharing resources as in the case of the client or server LAN. A peer-to-peer LAN is usually used in smaller environments than the client or server LAN. All connected devices share equal functionality, and the connection could be wired or wireless. And users can access databases, emails, share documents, print, and use other services. Let's talk more about LAN optimization. Starting with, why do we need it? Network performance should never be overlooked in a LAN because many businesses depend on their local resources to feed information to their customers on the WAN. LAN optimization offers various useful techniques. For example, active monitoring. Being able to monitor connected devices on the LAN can help system administrators to detect any abnormality. We will cover ways of implementing a monitoring system on your network with IP address management later in this course. Network segmentation. On the switches system, administrators can implement VLAN, Virtual Local Area Network, to segment any broadcast traffic. In other words, to create a partitioned computer network within the LAN. Implementing quality of service, QoS. The ability of dependently running high-priority applications and traffic under limited network capacity means that network engineers can have priority to some applications in terms of bandwidth, latency, etc. Every business needs to have a reliable network to be able to send and receive data confidentially and securely with its own LAN. Some of the benefits of optimizing a business LAN are reduced computing power. When a LAN has been optimized, there are some benefits of reduced computation in the network. For example, in a well-configured network, there is a simplified algorithm process in calculating the best path, load balancing, VLAN segmentation, etc., greatly reducing the processing time. Increased speed. In an optimized LAN, speed could reach up to 1 Gbps or more, which would greatly impact the speed at which sharing files to uploading and downloading and high-definition streaming on the LAN, providing all users with the speed needed in communicating with one another. Let's now move on to wide area network, WAN technologies. A wide area network works beyond the geographic scope of a local area network. In other words, a WAN is basically used to interconnect a section of LAN. This could be in the form of remote LANs, such as at branch sites or a campus LAN. As this diagram illustrates, a WAN connecting a campus network and a remote site enables users to share resources between the campus and the remote network through the WAN. A WAN is controlled by the ISP. Each user who wants to access the WAN will have to make an arrangement with the ISP to do so. This arrangement comes in the form of payment for their service. ISPs come in many different forms, such as a mobile service provider company, a telecommunication company, cable company, satellite service provider, etc. In this diagram, the ISP is the WAN. In fact, the internet is often considered a WAN because it connects users to other networks. Clearly, it's not feasible to connect all computers across different geographical regions of the world with physical cabling. That's why isolated LANs are created and interconnected with the WAN to save costs and increase the speed of transmission. With WAN optimization, businesses can interact with their customers. For example, Facebook can only be accessible through a WAN connection. An employee working remotely can connect to their headquarters. Users who need to send data across far distances make use of WAN technology. For example, a business owner in Dublin can very easily buy goods from the USA. WANs also make learning more easily accessible, particularly for students needing to do research. There are some common WAN topologies that are used to ensure there is smooth connectivity between LANs and the WANs. These are point-to-point topology, hub and spoke topology, full mesh topology, and dual-homed topology. Now let's look at each of these WAN topologies more closely. Just as the name implies, the point-to-point model uses point-to-point trucking between two routers in a network. This usually requires a dedicated direct physical link connecting the two routers for the data to be transmitted from one to another. This topology is very inexpensive to implement. The hub and spoke topology is sometimes referred to as a multi-point topology. It is usually implemented in companies where a private network is required. A dedicated direct physical link is connected to multiple point-to-points on other sites, and every communication has to go through the hub as shown in the diagram. The full mesh is a slight modification of the hub and spoke topology. In this case, all the routers communicate directly with each other with the use of a virtual path, but often require a lot of configurations and maintenance. The dual home topology is one of the best topologies to implement because of the redundancy it provides. As can be seen in this diagram, an extra router is attached for an enhanced network, load balancing, and transmitting traffic with the use of a virtual path to all the connected spokes. The drawback of this topology is that it is costly to implement. The type of devices that are used solely depends on the type of WAN technology that is being implemented. WAN technologies can either be packet switched or circuit switched. Let's look at these two types of WAN technology a bit closer. Do you remember in the first lesson of this course, we spoke about ARPANET? That is Advanced Research Projects Agency Network. We mentioned that this was when packet switching was first fully utilized. So what exactly is packet switching? Packet switching is a means of data transmission where data is broken into several segments and sent simultaneously. Each packet contains unique identifiers, which refer to payloads, and the header, which includes the destination and other pieces of information. This information helps to determine the links that packets should send over based on the addressing information in each packet. Packet switching does not require a circuit to establish communication, and they allow many pairs of nodes to communicate over the same channel. In the case of circuit switching, a dedicated circuit or channel is used between nodes to aid communication. For a communication session to be established, a virtual connection must have been set up first. There are various techniques that can be used to transmit data in a WAN. An overlay network is a communications technique where a virtual network is created on top of another network, typically a hardware and cabling infrastructure. Packet over SONET /SDH refers to a packet over synchronous optical network or synchronous digital hierarchy. Asynchronous transfer mode uses asynchronous time division multiplexing to encode data into small fixed-sized cells. And then frame relay is a technology for transmitting data between LANs or endpoints of a WAN. These systems are often replaced by Ethernet WANs. So why do we need WAN optimization? WAN optimization comes in handy when we need to improve our network performance. This is a very important cost saving for businesses as they do not have to buy and introduce new and expensive hardware. Instead, they can simply modify the existing configuration. Network engineers can quite easily upscale the software using recently developed protocols. Due to the high volume of traffic, many business WANs suffer from latency and bandwidth limitations. WAN optimization offers various techniques to try and solve these problems. For example, deduplication, which is eliminating duplicate or redundant information. Compression, which is reducing the volume of data. Protocol optimization, choosing the best protocol for different scenarios, traffic shaping, managing bandwidth in different scenarios, local caching, speed network access to data, software-defined WAN for simplifying and managing the operation of the WAN. Now, all these techniques improve packet delivery and data transmission either by allowing network bandwidth to grow or shrink dynamically as required. When a WAN has been optimized, there are a lot of benefits both for the network engineers and the users connected to the network. These include increased accessibility of resources. When the same files or resources are accessed repeatedly, those resources are readily accessible and saved on the cache, rather than resaving the files every time. Increased speed. When the computer processes do not need to compute the path to take every time a new connection is established, this greatly speeds up connection time. More secure and faster data recovery. When a server crashes, a business needs to be able to recover data quickly. If this is delayed, users aren't able to access their files and resources. SD-WAN. The initial WAN design was restricted to enterprise branch and data center. With the SD-WAN, companies can now adopt cloud-based applications across the globe. As we are discussing different network types, you may not know that you also get various types of private networks. An enterprise private network, EPN, is a private network most often found in big businesses where data is protected and resources are shared within the organization. A virtual private network, VPN, is an encrypted private connection from a device to another network across the internet to transmit sensitive data. Examples of these are ExpressVPN, Surfshark, and CyberGhost. And that brings us to the last network we'll be discussing in this lesson. Unlike LANs and WANs and private networks, personal area networks, PANs, exist in a limited network, such as a house. A personal area network, PAN, connects electronic devices centered on an individual person's workspace. This type of network can be wired or wireless, and it enables communication between computer devices in close proximity. With PAN technologies, end devices such as laptops, mobile phones, and tablets share data and resources. One of the most common examples of a PAN is the use of wireless Bluetooth devices to share resources over a distance of up to 50 meters, or wired connection methods such as USB or FireWire. The IEEE 802.15 is the standardized form of PAN technologies used in wireless networking. These standards include 802.15.1, the bedrock that established the wireless PAN standard based on Bluetooth version 1.1 specifically, which uses the frequency hopping spread spectrum, FHSS, and operates at a speed of up to 1 megabytes per second. 802.15.2, an updated version of the 802.15.1, which facilitates the coexistence of 802.15 PAN and 802.11 wireless networks. These versions help to connect devices to counteract the interference between the 802.15 PAN and 802.11 because they both operate using a 2.4 GHz frequency. 802.15.3, a newer standard for higher rate transmission in wireless PANs, where data rate ranges from 11, 22, 33, 44, and 55 megabytes per second. Consolidated with the higher data rates and QoS, this standard is good for multimedia purposes. 802.15.4, a newer standard also with low data rates that manage to lower power consumption for connected devices. This standard is more beneficial in devices where low battery consumption is required, like in the case of sensors, smart badges, etc. There are many benefits of PAN technologies. These include the following. They're inexpensive. PAN technologies are relatively cheap compared to other networks. They are secure. PANs are often viewed as more secure due to the fact that every device connecting to the network has to be authorized before data and resources can be sent across. Data synchronization. Connected Bluetooth devices can automatically synchronize data downloads and uploads and file exchanges simultaneously. And then portable. PANs are easily embedded into electronic devices and carried about in any location. PANs do come with some limitations though, such as limited proximity. There is a limitation on how far devices connected to PANs can reach. Slower data transmission. In comparison to other network technology like LAN and WAN, the data transmission rate is slower, particularly when there are multiple devices in the PAN. They're also prone to interference. As with most wireless networks, a PAN can be affected by lead materials, metals, magnets, walls, and radio wave signals.